Hey, I know a lot of you guys are gamers, and uh, honestly, I don't play video games, but my son plays a lot of video games, so I've watched a fair amount of his games, and not a lot of them that he plays are about solving puzzles. I think the subject of what they are about did not make it to the textbook. So you guys know, like Fortnite, Apex, those kind of games. I think you sometimes have some partners that you're playing with, right? And you show up, and I don't think it's random who you're paired with, but in this scenario, Anna shows up and she knows 10 people that show up to this game out of the 50. And they want to know, what's the chance that she is not going to be paired with somebody that she knows? And here's the deal. If she logs in and she gets paired up with somebody that she doesn't know, she turns the game off and then she logs back in and she hopes that she gets paired up with somebody that she knows the second time. So their question really comes down to what's the chance that she logs in, she's paired up with somebody she doesn't know, she logs back out, she logs back in, and she's again paired up with somebody she doesn't know. So it happens twice. Okay. So is the second event dependent upon what happens on the first event? Okay, so let's think about that for a second. On the first event, she logs in, she has a 40 out of 50 chance of not being paired up with a friend. So the notation is going to look like this. What is the probability that she's paired up with not a friend? Okay, sometimes like this, capital P confuses people. What's the parentheses about? It's not multiplication. It's just saying what's the probability of being paired up with somebody that's not a friend of Anna's. And so she has a 40 out of 50 chance of that happening. So that's event number one. Event one. Okay. So how about event two? She logs back out. She's not happy. She's paired up with somebody she doesn't know. And so what's the chance that she's again paired up with not a friend? Well, it's still the same 50 people. It's not like the first person that when she logged in, she got paired up with somebody she doesn't know. It's not like they removed that person from the pile and kicked him out of the game and said, no, you can't log back in. They're all 50 still there. And so she logs in a second time. She has another 40 out of 50 chance. This is where you use that independent, dependent thought process. You've got to determine in the second event, do my numbers change over here? Or is it still a 40 out of 50 chance? If they would have said, well, they took that person that she got paired up the first time, she's definitely not going to get paired up with them the second time that she logs in, then I think it would be down to a 39 out of 49 chance because she did log in like the first time and got somebody that she didn't know. So they kicked that person out. And now they would be down to 39 people she doesn't know out of 49. So that's how it's impacted if it was a dependent event. But this one is independent. Now, unfortunately, that's not the only thing we need to do here. Independent. I didn't spell that right. Dang it. Let me try again. Independent. Okay. So, what do we need to do? When you have two events occurring back to back, you're just going to use the multiplication rule. And the multiplication rule is figure out the probability of the first event, and you're going to multiply by the probability of the second event. So the probability of not a friend and, let me put this in all caps, and not a friend again on the second event would be 40 out of 50 times 40 out of 50. You can, of course, crank that into Desmos, but I see some easy simplification that's going to go on. That's 4 out of 5 times 4 out of 5 because both the numerator and the denominators can be divided by 10, right? And so we get 16 out of 25. Now, you have to be careful. Like, are they asking us to put it as a fraction? Are they asking us to put it as a decimal? Round to the right spot. So make sure you read that part carefully in the computer. That's how we're going to do these problems. We're going to multiply the two probabilities together of the two independent events. So the first, or these 5 problems right now are going to be all independent events. Thanks for watching my video.